Key characteristic that killer robots are controlled by humans because there's a line. At this point. So this is a YouTube screenshot. Boston Dynamics is a company that makes killer. I won't play you the video, but this is a. Well, you can. You can find it. It's on YouTube. It's uploaded in October 2003. It's this fabulous video of a killer robot, and basically it just spends 8 minutes running around the car park of this company in America that have designed this killer robot. And occasionally it sort of runs past the kind of a sort of fat, balding bloke who's holding a controller. And he's running around, he's running this killer robot now. And, but you see, at the end of the day, that's the point. The point is, it's not just the killer robot, it's the bloke with the controller. He's controlling the killer robot. So, the robot running around the car park is being controlled by a human. And the question is, could a computer control that killer robot instead? You see, could a computer, computers disruptive technology, computers like to relieve humans of their jobs, so could a computer control a killer robot? Okay, and in fact, we could go a step further. Could we write an app that people could download on their phone and, now I know how long I have. Could we download an app on our phone which when you type in someone's name into the app, then some killer robots are unleashed and goes and kills that person? So could there be a killer robot app? Can computers do that? So that's kind of an interesting question. So what would a company need in order to make that killer robot app? So firstly, they need a good database, right? Because the idea is you type someone's name in and it's going to find them. So you need names, addresses, and accurate information about the daily routines of billions of people. So secondly, we need some people that can write the app. So we need employees that are very good at writing computer programs. Thirdly, we need very good facial recognition software to make sure the killer robot kills the right person. Fourthly, we're going to need experience in kind of control. This is somehow one of the hardest parts. We need to control the killer robot by out of this car park and towards the correct person. And then fifthly, of course, we need an army of killer robots. So if we have all of those things, then we can write a killer robot app. So what's the company that has all of those things? How about Google? So let's have a look, right? Does Google have names, addresses, location of business people, absolutely. Right? Even if you don't have an Android phone, even if you don't have a smartphone at all, somebody you know, your boss, your work colleague, your wife, your granddaughter, somebody has typed your name and your phone number and your address into their Android contacts, and they've synced that contact list with Google, and Google knows what your name is, what your address is, and where you live, and your phone number too. So does Google have employees that can write good computer programs? Of course it does. Does Google have facial recognition software? Of course it does. I had an Android tablet once and I just looked at it and it would unlock. It was a very kind of cool thing. Does it have computer programs that can drive machines around? Of course it does, because it's currently spending a lot of money on self-driving cars. So the only question left is, does Google have an army of killer robots? And the answer is, well, you see, Google has a motto, which is don't be evil, which it quietly dropped in 2015. And possibly unrelated to that, in December 2013, Google bought Boston Dynamics and 7 other robot companies. And now suddenly Google own all these scary killer robots. Exactly. So how many killer robots have Google actually got? Probably enough to make it feasible to write that app. So actually, I think in theory, I've attempted to construct a proof that in theory, somebody at Google could write an app which really would have the property that you download it, you type someone's name in, and it unleashes several, I mean, you'd probably have to do some experiments to work out how many was enough, but enough killer robots to finish this person off. So that's something computers can do. I think at this point in time, all the ingredients are there. Okay? So this talks about what computers can't do, but this, I think, puts it into some kind of perspective. So here's another question. What about if a computer at Google was sentient and realized that it could, maybe it wouldn't need a human to write the app. Maybe the computer could write the app. Maybe it's very 2001. Maybe the computer could write the app, and maybe the computer could just decide to take over the world because it's got access to the facial recognition software and the database. Maybe the computer could just kind of go rogue and take over the world anyway. So maybe computers would find that appealing, but I'm not so sure, because for a computer to make that leap and decide that it's going to kill everyone in the world, the computer would have to be able to think. And I don't know if computers can think. So we've seen something computers can do. If somebody wrote a program, they'd kill everyone. But we've also seen maybe they can't think, okay? And in my personal opinion, I don't think computers can think. So here's a picture of 2 things. The thing on the left is Garry Kasparov. He was the world chess champion in 1997, which is when this photo was taken. And the thing on the right is what at the time was a very fancy-looking monitor. And that monitor was attached to a computer, and the computer was called Deep Blue, and it was made by IBM, and it was the best chess-playing computer of that time. So, world chess champion versus computer chess champion. This was a 6-game match played in 1997, and it was big news. Kasparov lost. And 1997 marked the era when computers became better at chess than humans, and since then all that's happened is computers got much, much, much better, and now there aren't any more competitions between humans and computers, because no human with any sense would ever dream of trying to play a computer at chess anymore. So who's thinking in this picture? Well, Garry Kasparov certainly looks as if he's thinking. I think that's a Sicilian defense. There are a few moves in, and he's probably trying to work out what the best move to play is. And he's using his intuition, he's using insight, he's using experience, he's also using psychology. Even though he's playing a computer, he's somehow played this computer before, he knows what kind of positions that computer plays well and what kind of positions that computer plays badly, and he's adapting his play to try and beat that computer. What's the thing on the right doing? Is the thing on the right thinking? I'm not so sure that thing is thinking. Is Deep Blue thinking? I don't know. What does a computer do? A computer is a device that's very, very good at following instructions very, very quickly, right? And that's different to thinking, in my opinion, right? So the basic logical instructions that a computer follows are contained in something called a computer program. And I'm going to have to tell you something about computers and computer programs in this talk, and I'm going to try and keep it simple, whilst also attempting to get to the difficult point. So let me tell you 2 things about a computer First thing, the computer has memory. The computer needs to store information, because sometimes it does calculations and then remember the answer and look back at the answer later. So a computer needs memory, right? Where the computer stores information. The computer program is typically storing the memory as well. And the computer also needs a processor. The processor is basically the bit of the computer that reads all the instructions in the program and does them one by one, very, very quickly. And sometimes the instructions say, go and do this instruction instead, jump over here. You know, the processor works very, very fast following these instructions. Okay, so nowadays, processors can process a 4 gigahertz processor. You probably have one of those in your phone now. That's doing 4 billion. Yeah, that's following 4 billion instructions per second. And so you can see, even in 1997, because IBM had a lot of interest in computers and were doing a lot of research into making computers very fast, that computer Deep Blue, it was analysing 200 million chess positions every second, right? So what was it doing? It was just trying all the moves, even the moves that were ridiculous. It would try moves that that piece I moved last time, let's just put it back. That's the kind of move it would try. It would try every single move, and it would try all the responses and keep going very, very fast, and then it would make some kind of guess as to which positions looked okay, and then maybe follow up with them. But Kasparov wasn't playing like that at all. There were many moves in a given chess position that Kasparov would not even consider, because he could see, he had intuition, he knew they were going backwards. But intuition ultimately gets defeated by brute force search, analysing millions and millions of chess positions per second. Eventually, we've now proved that computers can do this better than humans. So I don't think that's thinking. So I think we're kind of safe from computers going rogue and trying to kill us all. But you see, the reason I don't think it's thinking is because I do a lot of unloading the dishwasher. And unloading the dishwasher is a very mechanical procedure. There's a plate, and I know where the plates go. And there's the bowls, I know where the bowls go. There's the cutlery, and I know where the cutlery goes. And I just sit, just unthinkingly, I sit and put everything away. And actually, I even unload the dishwasher in exactly the same order every time, because I'm trying to be like a computer in some sense. And while I'm doing that, I'm thinking, right? And I'm certainly not thinking about what I'm doing. What I'm doing is somehow subconsciously happening in the background. What I'm doing, I tend to be thinking about mathematics, or whether I'm hungry, or what I'm going to do after I've finished unloading the dishwasher. You see, and that's thinking. And whereas the computer, when we have robots that unload dishwashers, they'll just unload the dishwasher, and they'll be gone. Right. So I need to talk about certain puzzles, we need to talk about problems and whether or not we can do them or not, okay? So I want to talk about problems, but the only problems I've mentioned so far have been very difficult problems. I've talked about the problems of, writing an app, that will somehow unleash killer robots. That's actually a very difficult problem for an engineer, because there's lots and lots of components that need to go in it. And somehow beating the world chess champion at chess is also very difficult. And what does it mean for a computer? Even trying to work out what the question is, do computers think? That's very, very hard. And different people have different opinions. So we need to talk about some simpler problems if you actually want to get anywhere. And what I'm going to do first, because I don't know how many of you are very happy with the abstract notion of a computer, I want to forget about computers as well, and I just want to talk about the idea of what the problem is and how to solve it, and how to know we've solved it, and also if we get a problem we're stuck on, then wondering whether that problem can be solved. I want to consider these ideas, and the reason I'm giving this talk really is because I gave a big course this term, and I thought a lot about proving things and how to prove things, and so one thing led to another, and I got very interested in this topic. So here's a problem raised by the ancient Greeks. Can I bisect an angle using ruler and compasses? So there's an ancient, 2,000-year-old problem. The ancient Greeks, we have Euclid, we were very good at this kind of thing. The ancient Greeks, they were very interested in this kind of question. So if I can have the visualizer on, I will now demonstrate what an angle is and how to bisect it using ruler and compasses. Bought this on the Holloway Road today, just the same as the one I had when I was in the sixth form. And lo and behold, pair of compasses, fabulous, and a ruler. And I've also pinched one of my daughter's felt chip pens. So, it is yours, I'm sorry. Here we go. So first of all, I need to draw an angle. So, there's an angle. That looks alright. Is that okay? I think that's okay. I don't need to fiddle. Can you see the angle? I think it's okay. There's a shadow. Maybe I shouldn't worry. And here's the angle, and what the job is, what's the question? The question is, can we bisect the angle? And bisect, as maybe many of you remember, bisect means I need to draw a line sort of just around down there, kind of exactly in the middle of this angle, as it were. I need to cut this angle into two equal pieces.